We all use AI assistants, right? But what if you could take them from being a jack of all trades and, well, a master of none, to being a true genius in one specific area? Today, we're going to dive into exactly that, how to transform a generalist AI into a specialized expert through a really cool process called fine-tuning.
So have you ever had this happen? You ask an AI a super specific question, and the answer you get back is technically right, but just totally useless. It feels like it gets the words, but completely misses the point. It's a super common problem, and it's because most AIs start out as generalists. They're trained on pretty much the entire internet.
And this slide just nails the difference. I mean, look at this. On the left, a base model's answer to how do I fine-tune a model is basically just asking you more questions. But on the right, the fine-tuned model gives you a perfect, step-by-step guide. That's the leap from generalist to genius we're talking about.
Okay, so this brings us to our first big idea, going beyond the base model. We're going to explore why a know-it-all AI isn't always what you actually need.
So, every powerful AI you've ever used starts its life as a base model. The best way to think about it is like a brilliant student who just graduated from medical school. They've read every single textbook, they have this incredible broad knowledge, but you probably wouldn't want them performing your heart surgery tomorrow, right? They're missing that deep, specialized, hands-on expertise.
And this is such a great way to frame that difference. The generalist AI is like your family doctor. It sees some skin irritation and goes, yeah, that's probably acne. But the fine-tuned specialist AI, that's the dermatologist. It sees the exact same symptoms and gives you a precise expert-level diagnosis. Now that's the power of specialization.
So the big question is, how do we get that specialist-level performance? Well, it turns out there are three main ways to get there. Prompting, something called retrieval-augmented generation, and of course, fine-tuning. Let's break down what each of these really means.
First up, we've got prompt engineering. This one's all about giving the AI super detailed instructions right there in your request. The analogy is perfect. It's like giving that doctor a very specific checklist for just one patient's visit. It guides the AI for that one single task, but it doesn't actually change the doctor's underlying knowledge.
Next, there's retrieval-augmented generation, or RAG for short. This technique is all about giving the AI access to outside information. So instead of just relying on what it's already been trained on, it can look things up in real time. This is like handing our doctor the patient's entire medical history and a library of the latest medical journals before they make a diagnosis.
And finally, we get to fine-tuning. And this is the most profound change of all. This is where you take that generalist base model and you train it again, but on a much smaller, super high-quality dataset. This is like sending our doctor to a multi-year residency to become a world-class cardiologist. It literally rewires their brain and makes them a true expert from the inside out.
So the whole key is knowing which tool to use for which job, right? Prompting is awesome for quick, one-off tasks. RAG is absolutely essential when the AI needs the latest, up-to-the-minute information. But if you want to fundamentally change the AI's core behavior to give it deep, specialized expertise, fine-tuning is really the only way to go.
Okay, so if fine-tuning is the most complex option, why would anyone bother? Well, that brings us to our next section, the power of specialization. Because honestly, the benefits you get from a focused AI are pretty amazing. And get this is the part that kind of blows my mind. A smaller, more efficient model that's been fine-tuned can actually perform better on its specific task than a gigantic, super expensive general-purpose model. Think about that. It's not about being bigger, it's about being smarter. It's better, it's faster, and it's cheaper.
Let's just run through the biggest benefits here. First off, performance. Fine-tuning makes the AI's answers way more consistent. And, this is critical, it seriously cuts down on hallucinations. When the AI just kind of makes stuff up. That means the outputs become way more trustworthy.
Second, and this is a big one, privacy. Because a fine-tuned model can be smaller, you can often run it on your own private servers. This is absolutely huge for industries like healthcare or finance, because it means your sensitive customer data never has to leave your control and get sent to some third-party company.
Number 3, cost. Yeah, there's an upfront investment to do the fine-tuning, but after that, your costs just plummet. Smaller models mean you pay less for every single API call, and you get your answers back a whole lot faster. It's a massive win-win.
And finally, benefit number 4 is reliability. When you control the model, you control everything. Its uptime, its availability, its content policies. You are no longer at the mercy of some other company's API going down.
You have a stable, predictable service you can actually build a business on.
Okay, this all sounds great, but how do you actually do it without spending a fortune? That brings us to Section 4, an efficient AI upgrade. We're going to see how to train an expert without having to build a whole new AI from the ground up.
The secret sauce is a technique called PEFT, which stands for Parameter Efficient Fine-Tuning. And the analogy here is just perfect. Instead of building a brand new custom computer from scratch, you're just adding a small, super powerful, specialized chip to the computer you already own. It's a slick, efficient upgrade.
One of the most popular ways to do this is a method called LoRa, and it's actually brilliantly simple. First, you take the original model with its billions of connections and you freeze them all, lock them in place. Then, you inject these tiny little new modules that are trainable, and finally, you train only those new parts. You're essentially teaching the expert a new skill without messing with its core knowledge.
And that brings us to the final and maybe the most important piece of the puzzle. Section 5, grading the new expert. I mean, after all this work, how do we actually prove that our specialized AI is any better than what we started with?
It is the million-dollar question, right? We've gone to all this trouble to create our dermatologist AI, but is it really giving better advice than the generalist? How can we prove it? You can't just sit there and grade thousands of answers by hand. You need an automated, scalable way to check its work.
And the solution is this really clever process called natural language inference, or NLI. Basically, you use a second AI to act as a referee. You give this referee a premise, which is the correct ground truth answer, and a hypothesis, which is the answer your newly fine-tuned model came up with. The referee's only job is to decide if the two statements logically agree, contradict, or are neutral.
In this slide shows you NLI in action and why it's so unbelievably important. The ground truth, the premise from a real doctor, says the symptoms are normal, but our fine-tuned model generated a response saying they could be a serious complication. The NLI referee instantly flags that as a contradiction. It's an automated fact-checker that can catch potentially dangerous mistakes before they ever reach a user.
So fine-tuning is letting us create these whole armies of AI specialists, each one a deep expert in its own little domain. And that leaves us with a final, really fascinating question to think about. As AI models become these hyper-specialized experts in fields like medicine, law, and science, what does that mean for the role of the human expert in the future?